All right, let's get into it. Today, we're tackling a huge shift in how we build technology, serverless AI. We're going to be drawing from some really sharp analysis by Chong Ho Alex Yu to explore this whole evolution. You see, what started as a simple tool for tiny tasks, what we call function as a service, or FaaS, has morphed into something powerful enough to run artificial intelligence. It's a fantastic story about breaking through old limits, rethinking costs, and honestly, changing the entire game for building smart apps.
So, let's start with a question that I'm sure hits close to home for anyone in MLOps or engineering. You've poured all this time and energy into building an incredible AI model. It's brilliant. It works perfectly on your laptop, but then you have to actually deploy it. And suddenly, it's a nightmare. The cloud bills are just astronomical and everything grinds to a halt. So what's the deal? Why is that last step, getting AI into the real world, so unbelievably painful and expensive?
Well, here's the twist. The problem usually isn't the AI model itself. No, the real villain here is our old way of doing things. We set up these big servers or Kubernetes clusters, right? We guess how much power we'll need at our busiest moment, and then we pay for all of it, all the time, 24/7. But here's the thing, most apps have unpredictable traffic. So for huge amounts of time, those powerful, expensive servers are just sitting there, doing nothing. But that billing meter, oh, it just keeps on running. This is the exact inefficiency that serverless AI was created to destroy.
And that leads us straight to the solution that started it all. A totally new way of thinking that promised to flip the entire economics of cloud computing on its head. This was the serverless promise.
Okay, so at the core of this promise is something called function as a service, or FaaS. Just think of it like this. Instead of renting an entire building, you just pay for a room only for the minutes you're actually using it. You upload your code, your function, and the cloud provider handles everything. The servers, the scaling, all of it. And the most revolutionary part? You only pay for the exact milliseconds your code is running. Not a single tick of the clock more. It's a total game changer. And the benefits here are just incredible. First, the big one, zero idle cost. If no one's using your app, you pay nothing. Simple as that. Second, the scalability is just instant and automatic. You can go from 0 users to thousands in seconds, and then right back down to 0 without touching a thing. For engineers, this is a dream. All that time you used to spend patching servers and worrying about operating systems, it's just gone. And what that means for the business is a much, much faster path to getting your product out there. Your team gets to focus on building amazing AI, not being system administrators.
But, and you knew there was a but coming, right? Here's where the story gets interesting. This serverless idea was amazing, but when the early pioneers tried to apply it to the heavy-duty world of AI and machine learning, they slam right into a brick wall.
This table really says it all. You had two completely opposite worlds colliding. On one side, you have early FaaS platforms, like AWS Lambda, that were built for tiny, quick, simple tasks. On the other side, modern AI models. These things are absolute behemoths. We're talking gigabytes in size. They need huge frameworks like PyTorch, massive files for model weights, and they can take a long time to think. It was a total mismatch in every possible way. And this wasn't just a philosophical difference. It was a hard, physical limit. I mean, look at that number. The original size limit for an AWS Lambda function was just 250 megabytes. Think about that for a second. A lot of basic AI models, even without all their extra code, are way bigger than that. You just couldn't do it. It was impossible. The door was shut. Now, let's jump to today. From 250 megabytes, all the way to 10 gigabytes. That is a 40 times increase. That number right there tells the whole story of evolution. It shows that the cloud provider saw the problem and completely changed the platform to welcome AI. So the big question is, how did they pull that off? It really came down to two brilliant breakthroughs. First, they let functions connect to external file systems, like Amazon's EFS. This was huge. All of a sudden, you didn't have to cram your giant model inside the function. You could just keep it on this external drive and have the function load it when it needed it. The second breakthrough was just as important. They started supporting container images, like Docker. This is what blew the size limit wide open, from measly megabytes to that 10 gigabytes we just saw. Now you could package everything, your model, your frameworks, all your code, into one neat bundle. The prison walls were gone. So, problem solved, right? The size barrier was history. Serverless AI was officially a thing. But as you know, in technology, when you solve one problem, you usually create a few new ones. And that's led to the new set of challenges and trade-offs we have to deal with today. And the absolute biggest of these new challenges is something called the cold start. So a cold start is what happens when a request comes in and there isn't a ready and waiting server for it. The platform has to spin on up from scratch. For a simple bit of code, that might take a fraction of a second, but for an AI model, it's painful. The system doesn't just have to start up, it also has to download and load your giant multi-gigabyte model into memory. This can add seconds of delay, which for any real-time app is a total deal breaker.
So how do we fight back against the cold start? Well, there are a few main strategies. The first is called provisioned concurrency. This is basically just paying to keep a few servers warm and ready at all times. It works and you get great speed, but you're paying for idle time again. It kind of defeats the whole zero-cost benefit of serverless. The second option is to make your model smaller using tricks like quantization, which helps it load faster. And the third, which is pretty cool, is using AI to solve the problem. You can use reinforcement learning to actually predict when you're about to get a burst of traffic and warm up the servers just in time.
But even if you solve the cold start, there's another elephant in the room we have to talk about: GPUs. A lot of the tech behind standard FaaS platforms, like what AWS Lambda uses, is built to be super lean and efficient. And that design choice means no support for hardware like GPUs. For a huge number of modern AI models that absolutely need a GPU to run fast, well, that's it. No GPU, no party.
So all of this leads us to the big business question: total cost of ownership. And when you look at it this way, the trade-offs are super clear. Serverless FaaS gives you that amazing zero idle costs and almost no maintenance work. That's a massive win. But you have to live with that unpredictable latency from cold starts. On the flip side, running your own Kubernetes cluster gives you rock-solid, consistent speed, but you're paying for it with high idle costs and a lot of maintenance headaches. It really just comes down to what you're willing to live with.
And that choice has created a much more interesting and diverse serverless world. It's not just about that original FaaS anymore. The real strategic choice today is between different flavors of serverless, where each one is fine-tuned for a specific kind of AI job.
Okay, now don't get lost in the details on this chart. The single most important part is that last row: optimal use case. This is your cheat sheet. Classic FaaS, like AWS Lambda, is perfect for all the behind-the-scenes glue code in your MLOps pipelines or for running high volumes of simple models that don't need a GPU. But if you're working with something more complex, like generative AI, you're going to need a GPU. That's where things like serverless containers from Azure come in. And for the absolute biggest, most performance-critical models, you have managed AI endpoints from Google, which give you the most power and control.
So, with all these amazing tools, where do we go from here? The future of serverless AI is being shaped by some of the coolest trends happening in tech right now.
Generative AI, of course, is changing everything. FaaS is the perfect tool for managing calls to big language models, and we're even seeing smaller, tiny LLMs that can run directly on regular FaaS. Then you have RAG architectures, where you give an AI extra context. FaaS functions are the perfect little messengers to go grab that info from a database real quick. We're also pushing AI out to the edge, closer to users for instantaneous results. And maybe the coolest part, the platforms themselves are getting smart, using AI to manage themselves. It's becoming a truly AI-native world.
So, to wrap this all up, what are the big takeaways? What should you actually do? First, and most importantly, match the right tool to the right job. Don't try to cram a GPU-hungry model where it doesn't belong. Second, fully embrace FaaS as the automation engine for your MLOps pipelines. Third, you've got to do the math. Figure out that break-even point between paying to pre-warm your functions and just running a dedicated server. And finally, get ready for what's coming. Start learning about vector databases and edge computing, because that's where this is all headed.
So I'll leave you with this final thought. Serverless AI isn't just a possibility anymore. It's a strategic necessity. AI is being woven into the very fabric of every single application we use. So the question isn't if you're going to adopt these ideas, it's how. Is your architecture right now a launchpad ready for the scale and economics of the future? Or is it an anchor weighing you down with the costs and headaches of the past? Because that choice is going to define whether you can compete in this new age of AI.